All right, guys, this next section is 7.3, which is integration by parts. Also known as tabular. So it is another way of figuring out antiderivatives. So first one is you either know the antiderivative off the top of your head. The other one that we learned last year was U sub, which is the backwards chain rule. This is another tool in our toolbox called integration by parts, and this is pretty much the product rule backwards. So you look at an integral problem and you kind of say like, all right, do I know what's antiderivative? No. Can I do U substitution? No. Then your next tool in your toolbox is this one, is integration by parts. And what it says is this. Is if you have the integral of two functions getting multiplied, so they say U times dv equals U times v minus the integral of v du. And this is what you need to know about integration by parts and the formula that you'll need. Best way to do this is by examples. So we're going to do a whole bunch of examples on this today and possibly tomorrow, depending on how long you guys get with the video. Now remember, with all these videos, as you guys get comfortable, you can always pause them and try to do the example yourself, then press play and see how I did it and see how close you guys got. Got it? All right, so let's do a nice straightforward example. So let's say I have the integral of x times the cosine of x dx. Now, as you look at this, you're like, all right, x times cosine of x, don't know the antiderivative of that on its own. If I separated it, I could, but I don't know the whole thing. U sub, where u would be x, and then it'd be u cosine of u, you have the same thing. It doesn't help you with anything. But if you can see that these are two functions getting multiplied, you can kind of tell that it's undoing the product rule. So first thing you do is figure out what your u is and what our dv is. So in this case, I'm going to have u be x, the first thing we see. That means dv, the derivative, is going to be cosine of x dx. From there, you've got to take the derivative of u and the antiderivative of dv. So you have to figure out what v was, the actual function is. Well, the derivative of u is easy. The derivative of x is just 1 dx, or just write dx. Here, the antiderivative of cosine of x dx is sine of x. So now what I have to do is put it back into our integration by parts equation. So remember, integration by parts said if I have the integral of u dv, it equals u times v minus the integral of v du. So in our case here, x cosine of x dx equals u times v. So it's going to be x sine of x minus the integral of v du. Now look what happens. V is sine of x. Du is just dx. And this made this problem so much easier to solve. You all know the antiderivative of sine, so you can just keep going with this. This first part doesn't go away. So you still have your answer. It still has the x sine of x minus, what's the antiderivative of sine of x? Well, the antiderivative of sine of x is negative cosine of x. Well, minus a negative becomes a positive cosine of x. I don't have any limits, so don't forget your plus c. And there you go. That's our integration by parts. All right, let's try another one. Our next example. do the integral of the natural log of x dx. All right. Now, if I knew the antiderivative of natural log of x, I wouldn't be doing this problem. But we don't know the antiderivative of natural log of x on its own. Can't do a u sub. There's nothing to substitute with a u. So, again, I have to figure out a u and a dv. Now remember, the u, you're eventually taking its derivative of to get du. The dv, you're taking the antiderivative of to get the v. Natural log of x is not going to be my dv. If I knew its antiderivative, I wouldn't have to do this whole problem. Got it? So that means natural log of x is going to be my u, and that leaves dx to be my dv. Well, what's the derivative of natural log of x? Well, we all know that's 1 over x dx. What's the antiderivative of dx? Well, what's really in front of that dx is a 1, and the antiderivative of 1 is just x. Well, let's put it all together. So my original problem equals, okay, u times v, so that's going to be x, natural log of x. Remember, that's part of your answer, minus the integral of v du. Well, v is x, du is 1 over x dx. Well, let's look at that some more. I've got x natural log of x minus the integral. Well, guys, what happens to x times 1 over x? They cross out, that just becomes 1 dx. Well, we already know that antiderivative. Again, easy problem for us. This just means this is x natural log of x minus the antiderivative of 1 is just x, no limits, plus c, and boom, there you go. All right, let's do another one. This one, let's add limits to it. All right. So again, I see two things getting multiplied here. Can't do a u substitution. So that means I've got to figure out a u, and I've got to figure out a dv. Now remember, the u is going to be a derivative of something, and hopefully a derivative of something that goes away. I'm going to say x, because the derivative of x is just going to be dx, and that kind of makes my problem easier. I'm kind of thinking ahead like a chess game. dv, that means it's going to be e to the negative x dx. Well, the antiderivative of e, remember we like e, it's easy, because the derivative and antiderivative are just the same. The antiderivative of e to the negative x is just going to be e to the negative x. We have to account for that negative and make it negative e to the negative x. So now let's put it all together. From 0 to 3, x e to the negative x dx equals, all right, u times v. Instead of writing x times negative e to the negative x, I'm going to make this negative x e to the negative x. Looks a lot better. Minus the integral, going again from 0 to 3, of v du. Well, that negative is going to go there. Minus the negative becomes a positive e to the negative x dx. We already did this antiderivative. I still have this first part, negative x e to the negative x minus e to the negative x. There's no plus c this time because it's going to go from 0 to 3. All right, stick in top. So that's negative 3e to the negative 3 minus e to the negative 3. Minus, stick in bottom. That's going to be 0, because 0 times anything is 0, minus e to the 0. Well, e to the 0, guys, we know is just 1. So minus a negative becomes, you have plus 1 over here on the right. This is combining like terms. This is like negative 3x minus x. So it's just negative 4 e to the negative 3. And that is our answer. All right. Let's go back to this example. I know we did this example already, but I kind of want to show you something and why it's called tabular. Tabular is kind of a shortcut to integration by parts. It doesn't work all the time for every integration by part, but it is a shortcut. With this, you have to come up with an f of x and a g of x. And it's very similar to what we've been doing before. Your f of x is you taking derivatives. And you want to take this derivative until it hits 0. G of x is you taking antiderivatives. Got it? So, if I look at these two things, I have x and cosine of x. Which of these two things can I take the derivative of until it gets to 0? Well, hopefully you guys all said x. Because what's the derivative of x? Is 1. What's the derivative of 1? Is 0. Boom. You're done. So now g of x means that's going to be cosine of x. And you're taking the antiderivative of cosine of x. Okay, well, the antiderivative of cosine of x is sine of x. And then you're taking the antiderivative again. Antiderivative of sine of x is going to be negative cosine of x. And you stop when it matches with the 0. Then you're going to go kind of diagonally. That's going to be positive. This will be negative. So your answer would be x times sine of x minus, because the next one's minus, 1 times negative cosine of x. Well, 1 times negative cosine of x is just negative cosine of x. 2 negatives make it a positive cosine of x. Don't have limits, so I have a plus c. And if you go ahead and look at your very first example, that's the answer that we got. So there's tabular for you. Nice, quick, and easy. All right, I'm going to stop this video right here. And then there's going to be another one of just more examples.